Hello, this is section 13.3 in your guided notes. It is hyperbolas, and the definition of a hyperbola, well, first of all, let's not skip ahead. Our objectives for this section is to locate a hyperbola's vertices and to graph hyperbolas centered at the origin. So let's talk about the definition of a hyperbola. Hyperbola is a set of points in a plane, the difference of whose distance from two fixed points called foci is constant. Foci is just plural for a focus. There's two of them. So we're going to be the same distance away from a focus, or from two foci. So they look like, let me scroll down here, they look like these things right here. They're kind of like sideways or stretched open parabolas. But there's double them. There's one up, one down, or there's one left and one right. And so you find out that, let's go back up a second, you get two standard forms for a hyperbola with the center at its origin. This one, which is x squared divided by a squared minus y squared divided by b squared equals 1. And this is the one that ends up sideways. Okay, it ends up like this and like that. And if you look at the other one, we got y squared written first over a squared minus x squared over b squared equals 1. And this one is the one that's vertical. So if y is written first, it's the vertical and 1. And if x is written first, we got the horizontal. And the vertices of these, let me go back down here to the picture. The vertices are right here at the furthest points, either left and furthest points right on them, or the furthest points on the bottom, almost or the top of the vertical ones. And the way we find them is it depends on what, first of all, is written first. If it's an x first, we know it's horizontal, and we would find them by taking the square root of this number down here, whatever it is. It's a, and it would be plus or minus a. And if it's vertical, it's still going to be plus or minus a. It's just the y squared tells us that it's going to be a vertical type like this. And so you'd get a point 0, a, and 0, negative a, whereas here you'd get negative a, 0, and a, 0. So if it's x up front, then the number that we take the square root of this number, that number will go in the x position for our vertices. If it's a y up front, the number will go in the y position for our vertices. So let's look at the next page and see how it works with numbers. Alright, so it says finding vertices from hyperbola's equation. Here's our two equations, a and b. We need to find the vertices for each. And in the first one we see that we've got x squared written here, so I know that it's going to be a horizontal hyperbola. So it would look like this, and the vertices would be somewhere in here, and we take the square root of this number to find out where they are at, and it's going to go in the x position because the x is written first. Sorry, I circled the wrong thing. And so what we get is, if we take the square root of 16, it could be plus or minus 4, which means our points for our vertices are going to go in the x position are 4, 0, and negative 4, 0. And if we plotted those, that's how we graph. We'd plot these points, and then we'd make our horizontal hyperbolas. For b, you see you got y here, so now it's a vertical one, and the square root of 9, which is plus or minus 3, is going to go into the y position, which would be 0, 3, and 0, negative 3. Those are our two vertices, and it would go like this. So pause here, try your checkpoint. When you come back, I'll give you the answers. So checkpoint 1, the vertices are at 5, 0, negative 5, 0. And for B, it's going to be at 0, 5, 0, -5. Alright, well, let's talk about asymptotes on the hyperbola. You should remember from Algebra 1, you should have seen them, maybe you didn't. But an asymptote is a line, it's a line that the graph itself, so our hyperbolas here, it'll get closer and closer to the asymptote, which these are the diagonal lines that make the X here. So these diagonal lines are the asymptotes, and these lines, the hyperbola will get closer and closer to these lines, but it'll never touch them, and it won't cross them. And these lines always end up going through this origin, because it's a hyperbola centered at the origin, and it goes through the corner of these boxes that end up being where the vertices meet the square root of the whatever b is, whatever b squared is, sorry, the square root of b squared. So that'll be on the up and down if it's a horizontal hyperbola, and it'll be here and here if it's a vertical hyperbola. So you'd plot your vertices, and then you'd find these either on a vertical one it's either here or here, on a horizontal one it's here or here, and then you make this box, and once you make the box then you can draw your asymptotes through, and then you're going to make you draw in your hyperbolas that will hit your vertice and get close to your asymptotes. So that's how we would graph a hyperbola. So let's look at trying to do this. And I don't know if it's on this. Nope, next page. Alright, example 2. So we're going to graph this hyperbola. So the first thing we want to know is we want to know our vertices. And we see we got an X here, and so our vertices are going to go, the square root of 25 is going to be 5 and 0 and -5 and 0. These are our vertices. So 5, 0, we can start plotting them. -5, 0. Oops, that's 6. 5, 0, -5, 0. So we know we're going to have a horizontal one because our vertices, the hyperbola will go through our vertices, so it's going to be a horizontal. It'll look like this. But we also want to make that box for the asymptotes. We're going to take the square root of 16, which would be plus or minus 4, so we're going to use that to get those other 2 points to make our box, which would be 0, 4, 0, -4. So you are going to take the square root of both numbers when you do graph these. The difference is whether it's a vertical hyperbola like this one will be, because that'll depend on what the first number that'll tell us. Or I'm sorry, this is a horizontal. I said vertical. This is a vertical hyperbola, and then if the y is written first, it'll be a vertical hyperbola, and this one's a horizontal. So these are the vertices, but these points here will help make that box that'll make our asymptotes. And so if you connect these boxes, or connect these points and make the box here, I'll make a dotted line. And then we are going to, let me move this over just a little. We're going to draw a line that goes through the corner of this box, through the center, and through the other corner, a diagonal line. So we're going to make it dotted too, because asymptotes are usually written as dotted lines. Okay, there's our asymptotes. And now we know we've got a horizontal hyperbola, and it goes close to these asymptotes, so it's going to come down through here. It's going to hit that point and go through there, and it's going to keep going on, so we draw arrows. And the same thing on the other side. there's our graph for x squared divided by 25 minus y squared divided by 16 equals 1. Try it on your checkpoint, and when you're done, I'll give you the answer. Okay, checkpoint 2. Still got a horizontal one, horizontal hyperbola. You would have it at 6, 0, negative 6, 0, and 3, negative 3. Draw the box in. Draw your diagonal asymptotes. And then draw your hyperbola. There you go. Let's look at the next. Example 3. Now, here we got a graph of hyperbola, but it's not in standard form. And we also know, if I went back to the standard form, it has to equal 1. And so, just like in an ellipse, if it doesn't equal 1, we got to make it equal 1. And so we divide by 36. But we divide everything by 36. And just like with an ellipse, the numbers will swap. It's going to be y squared over 4 minus x squared over 9. When we reduce it, equals 1. Okay, so we've got y squared written first. So my vertices would be the square root of 4. I would get plus or minus 2. And it's going to go in the y position. So 0, 2, and 0, negative 2. But we're also going to have to make our asymptote box, we're going to have the square root of 9, which is plus or minus 3. And so we would have, for the x position, 3, 0, and negative 3, 0. So let's plot those points. 0, 2, and up 2 and down 2 from the origin. Negative 0, negative 2. And then 3 and 0, 3, 0, and negative 3, 0 are to the right 3 and left 3 from the origin. I'm going to draw in the dotted box. And then our diagonals we'll draw in going through the corners and the origin. And on the other side, draw the X. And this time we've got a vertical, because these two, the top and bottom ones, are my vertices. And so we got a vertical one that goes like this, vertical hyperbola. There it is. Try example or checkpoint 4. When you come back, I'll give you the answer. All right, checkpoint 4. I'm sorry, checkpoint 3. I said checkpoint 4 before. This is checkpoint 3. You're going to have the equation will be y squared over 4 minus x squared equals 1. X squared would be over 1. Okay, so your vertices are going to be vertical ones, will be up, down 2. Then to make the box, we got to go, the square root of 1 is plus or minus 1. So we go up the left and right 1. We'll make our dotted box here. And then we draw in our asymptotes. On the other one. Whoa, that's not very good. Try that again. And they are vertical vertices. I missed a little bit, but you get the idea. There's our hyperbola. that is all for this section. I'll see you in class.